Welcome back to our class. Today we want to look at lambdas and closures and how they are used, when they are used and how they are used. So why do we require lambdas and why do we require closures? And of course, I'll define what they are so that we get to know what they are also. So I've said in many terms, we often need small temporary functions for one, adding a fixed value to a number, or two, filtering or transforming elements in a list. And we may also require this small temporary function for handling an event or callback. So that is motivation. Require temporary functions, small temporary functions for doing this. And why I do this is that sometimes it becomes a lot of work writing a full function for each small task that we have, or not even if it's not a task, it may also be repetitive, so that you are repeating the same function every time, or it makes your code harder to read when the logic is supposed to be read. So also there is that use numbers how to use functions. Just functions using for this in the event that number a fixed value to a number, or you want to do filter, you want to filter, transform and list. Let me share first of all. Let me say, for instance, you want to handle an event callback, so you may want to use lambdas and closures. So lambdas lets you write quick instructions without naming them. Later on, we'll see closures, which are just special lambdas that can remember variables from their surrounding. So lambdas will just be letting us write quick and functions without letting them, but now closure will just be special lambdas. So later on, we'll so therefore, what we're saying in short is that lambdas and closures help us write more flexible and readable code without repetition and making logic shorter, so that you don't write very long things where you would have shortened. So that makes it concise and flexible and easy to read. That is why we require this lambda. Log Now, so our introduction, let's look at what lambdas are and how to use them. Then later on, we'll look at what closures are. Of course, we've said that they're just special lambdas, and so we will later on be seeing how they are used. Now, lambdas are also known as anonymous functions. Of course, we've said that we are using them without naming them. Just again, take you back to that. That's why we're calling them anonymous. So I'd say here that lambdas let you write quick inline functions without naming them. That is why the word anonymous comes. They're called lambdas, or we can also call them anonymous functions. Now, what this then means is that they do not have a name like the regular functions. They're also, lambdas are also useful when you need a small piece of code for a short time, such as passing a function or as an argument. So they have these two functions mostly is why we use them. Now there is syntax here. Okay, that's good. The syntax, we have two lines. Then it have argument. So return expression. Now, so this part between the two pipes, the part between these two pipes would list the parameters that would then be. And after the pipe, you write the expression whose value will be returned. So we have the two pipes, and then inside we have the expression, the parameters. Inside we have the parameters, and then just out after the pipe, you get it to write the expression whose value will be returned. So I think let me now show an example of how we use lambdas, a code for that. So look at this small add 50, and then equals the part here, then val plus 50. So these are the parameter, and then what is supposed to be returned, the expression whose value will be returned will be val plus 50. So this lambda adds 50 to the input value. So the input value, then it adds 50 to it. Then we have assert, add 50 So you are asserting that after you added that input, add 50 to it, the result will be 100. No, the result will be 150. So that is the input at this point is 100. So then you add 50 to it, the result will be 50. So lambda in this case is called with 100. So if it's called with 100, and then you add 50 to it, the result then becomes 150, and therefore that is what we assert. Now you can see the code has been shortened. It's a short code, and we have used it to add values. As we had said, that is one of the uses of Lambda. So just about this code, what we see from this small code is that Lambdas lets you write quick, reusable bits of logic without needing to define a function. So you cannot, from what you see, you cannot define any function, just written direct. And this code is reusable. You can use it, you can change values and so on, use it for any other input. Now, the first line says, let add 50 equals to a lambda val plus 50. So we need to understand what it means or what it does, what this line does. So this line creates a new variable that is called add 50. Add 50. So that is this 50. We are adding 50. The value assigned to it is a lambda function, or what we also call an anonymous function. And this value takes one argument, that is val, and returns val plus 50. In other words, add 50 is a function that will add 50 to any other value give it. So if you were to change this value and make it 150, then this function would give us, the return value would now be, if this is 150, the return value will be 200. That is what the return value will be. Now, if you make this to be 90, then the return value here will be 90 plus 50, which is 140. So that is what this first line does. The first line does what we just said. It creates a new variable, which we call add 50. That's a new variable. And then the value that is assigned to it is a lambda. The value that is assigned to that variable is a lambda. And so it takes one argument. So like, for instance, 100 is one argument, takes one argument, val in this case. And once it takes that, the result becomes val plus 50. Now, what about the second line, which says assert? Now, this line, then it checks that add 50 lambda works correctly. So it's just checking that the function above is performing as required. So it calls add 50 with 100. So our val becomes 100 this time. And then the lambda computes 50 plus 100, and the result is 150. That is the result that is returned. So if the assert statement is correct, then it means the above statement is also correct. Because what the assert is doing is just trying to verify that what is above it is correctly functioning. So if the program, if it's correct, then the program continues. If it's not correct, then the program would stop with an error. That is what the assert is doing, just to confirm that the program is working as expected. If it's not, then an error would crop up. But if it's correct, then it will work properly. So that what it means, therefore, is we have created a function that adds 50 to its input and then tested it to make sure it works as expected. So you can try this and just try it. You open your WSL, begin a new project, and try to copy paste this and see if it works. Okay, that is okay. Let's now look at lambdas with the block bodies. Now, what I mean by block bodies, I just mean lambdas inside with these curly brackets. So I said lambdas can have a block that can be enclosed inside these curly brackets as their body, not just as a single expression. So the example we had prior was just a single expression. You can see is not enclosed in any curly brackets. We are saying that we can also have it enclosed inside the curly brackets. Now, why is this important? It's useful when you want to perform multiple steps or use the local variables within this. And this is an example. Let cool be these pipes and then equals. Let x be 100, let y be 100, and then their sum. Then we assert cool just to verify that whatever is above, the function above is correctly working. So we assert that. So this is an example of lambdas with block bodies. And I've said why it's important. When you want to perform multiple steps, like you can see, there are several steps here. And there can even be more than what we have. You can also use it if you want to use local variables within the lambda. So that is the other time you can use block bodies, lambdas with block bodies. Now, just looking at this example, I want to explain what each of these lines mean and what they're used for. The first line, let cool, this first line coming up to here, not even the first line, the first part of our code from this part to this part, creates a lambda function with no parameters. The empty, so you can see this part is empty. Our pipes has nothing, has no parameter. It's not like the first example we had. The first example, our lambda, our pipes had the parameter inside. Our pipes had a parameter inside in our first example. But in our second example, we are saying pipes without parameters. But then after the pipe, we have a curly bracket, and then inside the curly brackets, we have our code there, our commands. So this is how we write Lambda with the block with the block bodies. So we must have these pipes which are empty without any parameter inside. Now let's now get inside this block. Let's get inside this block. Inside this block, we have two local variables, x and y, that are created and set to 100 each. So those are local variables. And it's, of course, again, just to emphasize the use of lambda. We already said you can use them. When you're using it with the block bodies, you can do that if you want to use local variables within the lambda. So this is the example, therefore, that suits this, this role. So you can see my x and y variables, local variables here, have been set to 100 each. Now, after that, we have the last line after these local variables. Now we are summing the local variables to get x plus y, which is a value that the lambda will have to return when it's called. So when you call cool, then it must return the sum of those two. Now, so that then takes us to the assert part. Assert cool is equals to 100, calls the lambda with no argument, calls the lambda with no argument. Let me just take you back to our first example. We called our lambda with an argument 100 in our first example. Our argument was 100, our val this time was 100. And of course, we said this val, you can change it to any other argument and see whether the sum is correctly computed. So you can always change it. So for this example, our lambda was called with an argument. In this other example, our pipes here are empty, there's no argument, and therefore, again, in the calling, you call without an argument. You can see this point, there's no value. Now you can try to put there an argument maybe and see, but now why? There's no need because our values are already assigned. X has been assigned, Y has been assigned. So when you say X plus Y, it's understood that we get the sum from these two. It's understood. But this other one, we had not given the argument. It was just val. It was just val. So this was reusable. That means this val can change to take any argument. So when it changes to take 100, it can also take 150, also change to take 1,000 and so on. So this one is reusable. For you to reuse this, then you must change the values of X and the values of Y. And then of course you would again change the assert equals to 200. It will also change. The 200 will change. So what I was saying is that the assert part calls the lambda with no argument, and this returns the sum of X and Y. In our case, the sum is 200. So just as before, the assert part checks that the result is correct. So just verifying that the above argument, the above is performing correctly. Okay, just a minute. Just a minute. Okay. So in summary, therefore, using these block bodies as we've seen in Lambda, uh, the first example, we did not use block body, and so that one cannot do complex work. But if you want to do more complex work, then you would require the block body. The complex work here means, like, for instance, you may want to declare help variables before returning the result. So in cases where you require to declare help variables, then the block bodies would really assist us. Now, so that is about lambdas. So right from the definition, what they are, how they're used, so if you want to do minimal work or if you want to do complex work. But in short, we've seen that they have really assisted us in very many ways. For instance, in making our codes readable, making our codes shorter and concise, so are very much useful. So if you're writing, for example, Noir circuit, and you want it shorter, you want it concise, then you may want just to use lambdas. If you want to do simple tasks, and then you would use an example like this example where you don't have block bodies. But if you want complex examples, complex tasks, for instance, you want to declare helpers, and then you would want to then you come and use block bodies. So that is about Lambda. So then we want to look at closures. And from the very start, I'd already told you what they are, just being special types of lambdas. So if you understood what lambdas are, then it becomes easier for us again to understand closures. So just as to recap again, closures are a special kind of lambdas, of course, or anonymous functions. We say the lambdas are called anonymous functions also. And these closures can remember and use variables from place where they were created, so they can remember. That's what we said when I was introducing. I said, let me just take you back there. I said lambdas lets you write quick inline functions without naming them. But closures, which are special lambdas, can remember variables from their surrounding. Can remember variables from their surroundings. So that is the part I'm emphasizing this time, because it will now be important for us remembering variables from the surrounding. So closures are special kind of lambda that can remember and use variables from the place where they were created. Therefore, this is different from the regular functions we know, because the regular functions would only use variables passed to them directly as parameters, but they not be remembering them from where they were created. So that is what makes this difference. Now let's look at this example. You have the main function, and then at this point, we now define our variable x as 100. And then let closure, we have this empty pipe. Then after that, we have the result that comes out, x plus 150. But x has been defined to be 100. So closure is able to remember what x was defined to be. So we don't need to bring 100 at this point. You just recall, to recall that x was defined earlier as 100. So it remembers x from its surrounding environment. That is what we said, that closures are a special kind of lambda that can remember and use variables from the place where they were created. So you can see we created x at this point. Then when we come later and use it, closure is able to remember, to recall and use x. Now we go to assert, then call upon this closure without a variable here. It should give us 250. So this is just to confirm that our above values, our above code is correct. So when you call closure, it returns the result as 250. So you can see it remembered that x is 100. Otherwise, if the result here is not correct, if you make this one a different value, then you'll get an error because it knows what x is. It knows that x is 100. So again, you can write this code and just try to see that this works. Okay. Okay, so that is how it works. So let me just explain this example line after line. Now, the main function, this is the main function, and the first line, x variable is defined inside this main function. Then we have this closure without any parameters. You can see inside our pipes, there's no parameter, but it's known what x is. So the pipes are empty, but inside its body, it uses x. So x is coming from the outer scope. So we say the closures would then remember what x is from where it was created, from its environment. So when you call closure, when you call this closure, it looks up for the value of x, and then when it gets it, it adds it to 150 and returns the correct result. So this ability to capture or use variables from its environment is what makes a lambda a closure. So if lambda can recall values from the environment, then we call it closure. So therefore, closures can remember the values of variables that were in scope when the closure was created, even if those variables are not parameters. Even if they are just not parameters, it would still recall them. Now, is this important and why? So we say it's useful because one, it allows you to write flexible and powerful codes because your lambda can use values that were set outside of it. For example, settings, counters, or other context. So many programming tasks, especially in functional programming and even in the event handling, use closures because of this very important feature. So it's something that we also need to learn how to use, do a lot of exercise with it, and perfect in its use. So just as a summary, closures and lambdas that can access variables. No, closures are lambdas that can access variables from their surrounding, then make them more flexible than regular functions. Now, we can also use closures to higher order functions. And again, I just take you through, and from your end, you can again do exercise on this. In our next class, we again be looking at now higher order and more complex examples, hands-on. That is in our next class. So how do we pass closures to higher order functions? I begin by just considering this example, then explain how it works as we progress. Now consider this function. The main function, we have let x, y be 50-50, assert that x plus y is 100. In my problem, I state that closures capture environment. Closures capture environment affected. Does this for a mean? What is it used for? I've said for expects a regular function, but the closure captures variables. For expects a regular function, one that we are used to, but closure captures variables. So we look what Okay. So about the syntax, sorry for that. I will look, just looking at the same example as I explained. The part inside these pipes lists the parameters, as we had already said, of the closure, just like the parameters of regular functions. So just inside these pipes, that is what we usually do. Would then list parameters of the closure. Now, the code after the pipes is what we call the body of the closure. And this is the code that will be then executed when the closure is called. So for instance, if it is val plus 50, so then the closure will be looking at, let me say x plus 50, for instance, and x has been defined above. So when you then call the closure, it then performs x plus that 50. It recalls what x was defined and then adds 50 to it. But this part comes after these pipes. And it's what we call the body of the closure. What about capture environment, where the variables are defined? So any variables that are used inside the closure body but are not listed as parameters are captured from where the closure was created. And this then means that the closure can remember those variables outside this where it's defined. So it has the value with its value from its environment. So let's look at this other example. So we have the pipe with an x, and then outside we're saying x plus y. So x is a parameter. Its value will be provided when you call the closure. Y is not a parameter, but is used. So closure or head when what it does. It's supposed to remember that. Now, so the environment, a list of types of captured variables. So I was saying that args are argument types, or what we call parameters. For example, if x and y are integers, then the type might look like function, field, and then the result will also be a field. So where the first term is the x and the value, the value, the sample value will be the y. So these are both integers. Also here is running fly. And then the result, of course, if you are together, elements of a field together, you're adding elements of a field together, and the result is then the field. Okay, so in summary, closures not only take parameters like use capture, um, they use or they capture variables from the place they are defined. Now let's look at generic or functions. And why is this important? Why or function, no matter what variables it captures from its environment. So in such a case, if that is what you want, then you may want to use generic higher order functions. So the solution to this is just to make the higher order functions generic over the closures environment type. So maybe if I be looking at an example, it will make it very clear. So that then means that our function can accept closures that capture any number of or any type of variables, as well as regular functions that capture none. So here is an example. We have defined x and y as 50 and 50. Then we assert that x plus y gives us 100. Also assert that 60 would be 60. Now, this is where the closure captures nothing. It compiles and runs closure captures nothing. Closure that captures nothing. So it will give us that 60. So we have 4 defined with the generic type. This is to allow 4 to accept any closure regardless of what it captures. You can see 4 and then field and so on. Now, but in this case, this assertion here, it will capture x and y because x and y have been defined to be 50-50. So it captures x and y. And so when it does that, it gives us a result that is 50. So if that happens, then it means this function is well defined. But in this case, It's capturing something that is not there, nothing. So it captures nothing, and again, gives us the correct result. So explanation just to this example. Now, the first line defines for as a generic function that accepts a closure of any environment. So the type is environment. Type is environment. So it will accept closure of any environment type. The second line, the closure. This captures the variables x and y from the surrounding scope. The surrounding scope is where they were defined, where x and y were defined, and they were defined here as 50 and 50. So that line assert for, it calls for this closure and then captures, that line captures the values of x and y from their surrounding. Now, the last one, we said that the closure pipes and then 60 captures nothing from the environment. There was no definition of course, this, we are not adding anything that has been defined before. So there's nothing to be captured. So it captures nothing from the environment, but then it gives you 60 as a result, just to show you that what has been defined as a function above is working correctly. For can accept both types of closures and regular functions because it is generic in this case. It's generic over the environment. So, and we already said the advantage of this is that it makes functions more flexible and reusable. So as a summary on this, we would say that by making higher order functions generic over the environment, you allow them to accept any closure, whether it captures variables or not. So like in our last example, so we allowed it to accept a closure first, where it would capture variables from the environment, and two, in the case of this 60, where it could not capture anything. So you can see that is the advantage of making it generic. So all in all, this topic of lambdas and closures is very important in your writing of circuits, and is something you need to do practice on, and so that you are very well familiar with it, and you can use it properly. One, in adding a fixed number to the value to a number, or filtering, or transforming elements in a list, or even handling an event or a callback. You can always use this. And of course, we've seen what lambdas are, and we've seen how closures are just special types of lambdas that can recall and capture variables from their surrounding. We've gone through how to write circuits, and specifically using lambdas. And then we went through how to write, again, same circuits, to use lambdas with blocks or block bodies. And we saw, again, how block bodies were important, especially where you want to perform multiple steps or where you want to use local variables within the Lambda. So again, we saw that as being very much important for us. From there, we came and looked at passing closures to higher order functions and how that is important. And then lastly, came to look at generic higher order functions and again, how that is important. And we've looked at an example where it's applied and how you to apply it. I think that is okay for today. That's enough. What it remains is just now exercise on your part. Try and exercise this. For the reasons we've already listed, to make your code concise, short, so that you're not writing very many things, repeating yourself, and so on, using a same function all the time, making it repetitive, and so on. So you can use these lambdas and closures just to avoid that repetition, make your code short and concise. Thank you.